in the straight line equations thing that you have in your notes, yeah, the equation of a straight line, if you have a graph, is given by y equals mx plus c. All right. Now, what that refers to, x is your variable, right, along the x-axis, as you know. Y is the vertical one. All right. The way they're related, the m in front of the x, that is the gradient. That tells you the slope of the line. The bigger that number, m, the steeper the line, the smaller the number, the shallower the line is. Okay? And the point is, that number can be anything from a negative number to a positive number, a fraction, etc. All right? C is the y-intercept. So that is where the line crosses the y-axis. And I'll give you an example of that now. All right, so if we have that, your xy axis, like that, and imagine we have a line that does, I don't know, from here, okay, roughly speaking, all right? It's a little bit off, but roughly speaking. So imagine that that's crossing the line there, all right? That is C. Okay? So that's your y-intercept. Okay? And the gradient is how steep that line is. Okay? Now, I'll explain in the next bit different gradients and what they look like. So if I go back to a standard grid, yeah, right, something like that, all right? And let me change this. If I have whoops, let's undo that. Like that, yeah? And I'll explain the numbers and how you work it out in a moment, but I just want to visually show you what different gradients look like, roughly speaking. That is a gradient of 1, okay? It's exactly, as you can see, halfway. The angle is exactly halfway between the x and the y axes, all right? So that is a gradient of 1. If I had, for example, let's see, there and there, that would be a gradient of 2. M equals 2. All right? And similarly, there to there, like that, that is actually m equals half. So do you see how different gradients, right, have different slopes? Okay? The steeper the line, as you get steeper, you're going in that direction. So that's a higher gradient, all right? And all the way down, you can have m equals 0 when it's a flat line like that. Okay? Similarly, what number should I use? Color, hang on. Yeah, let's use this funky color here. All right, so the other one, exactly the same sort of numbers, But watch this. Okay, and let me do what's the best way to do this one? There and there. Like that. And one more. Like that. Okay, these ones, what I'm trying to demonstrate there is that this line, the shallow one, is m equals minus half. This one is m equals minus 1. Okay. The reason these are negative is because as you go from left to right, the lines are going down. All right? So here's the rule. If the line is going down like this, that's a negative gradient. Okay? And if the lines are going up like that, then that is a positive gradient. Does that make sense so far?
Yeah.
Yeah? All right. Then, if you had to, for example, there's two ways that the questions come up. One is sketch or draw a line that, for example, has equation that 2x plus 3, for example. All right. So what you would do in your normal sort of grid system, okay, do that and sketch a thing like that. You know, because of the plus 3, that's the y-intercept. So we know that it goes through the value 3 on the y-axis, like there. That's where it's going to cross the y-axis, right? Then the gradient equals plus 2. So it's a positive number and it's a 2. So we know it's going to be going up, left to right, and then we just have to pick a numbers. Now, what does that gradient of 2 actually mean? All right. And I'm going to put it into some just plain English. Plus 2, a gradient of plus 2 means 1 across and 2 up. Do you understand what that means now?
Yeah.
Yeah? So if we start with the point of 3, you're going 1 across and 2 up. So that's going to be the next point there. Okay? And if we go backwards, go 1 across this way and go 2 down. So there and there. All right? That allows us to now draw the actual line. Like that. Do you see?
Yeah.
Does that 1 across 2 up thing make sense now?
Yeah.
All right? The gradient of, well, whatever number it is, 2, what it means is for every unit of x that you go across, how far up or down do you go vertically? All right? Any questions on that? No? All right. So that's how you do that. Vice versa, if I had a different line and I was asked to find its equation, all right? So what about, I don't know, let's do something like this. So I have that line and I need to find the equation of the red line there, okay? On the graph, let's say I can read that it crosses the y-axis at 1. All right? So I know the equation is going to be of the form mx plus 1. So in other words, the c bit I already know because I know where it crosses the y-axis. All right. What I need to find is my gradient. Again, that's what your teacher's given you in terms of working out on that worksheet, all right? The way to work out the gradient, I'll explain the mathematical bit in a moment, but we can do exactly the interpretation of that, you know, that how many across and how many up, right?
Yeah.
So imagine I start at that point 1 on the y-axis, so there, all right? And I go, in this particular case, if I go 1 across on x, I've sort of gone halfway up the square, haven't I?
Yeah.
You can
so,
see. Yeah? Go on.
Yeah.
You're going to say something?
No.
No? All right. So I would rather, and this is what you should do in exams and tests, is go a little further across until you've got 2 whole numbers for across and up, down, right? So if we go 1 more square, look at what happens. We're up to that corner there. So we've gone 2 across and we've got 1 up. Does that make sense?
Yeah.
Yeah? So in this case, remember what I was about to show you, the maths version of it, i.e. the algebra. It's called the y difference. Divided by the x difference. Does that make sense?
Yeah.
So in this particular case, the y difference, in other words, how far up or down we've gone, it's actually +1. So we've gone up 1, and how far across we've gone is +2. All right? So the gradient in this example turns out to be 1/2. Okay? So therefore, the equation of the line, this red one, is 1/2 x plus 1. All right? And just to avoid a little confusion, when you see them in books and textbooks, whatever, this 1/2 x can also be written as x over 2. That's exactly the same thing. All right?
Okay.
You can write it whichever way you like, as long as you know what the gradient is and it's clear to the examiner or whoever's marking your tests and questions. All right? Okay. So the first rule is that the gradient is given by, on any line between 2 points, is that thing there. Okay? And which I think you already know. All right? That's fine. And then the other thing I wanted to show you actually, if you have, I think in your questions, you have a line, let's say, as an example, line of gradient three, and it passes through I don't know, a point. Have you got one in your questions there? Let me see.
Which one?
Just trying to think which one is. You've got all sorts
Because
of.
there's 2 parts.
Yeah, it's in the top one. I'll change that one because there's one particular question you have there which we can do, which I think you've done
The
already.
line has a gradient 2 and passes through 2, 1.
Okay, let's do 3 and 2, 1 then.
Okay.
I'm not sure what numbers we'll get, but we'll try it, okay? So when you have that kind of a question, you know that your equation of the line is going to be, remember that's m, and we need to find what c is. So you've got 3x plus c. All right, that's the basis of the equation, okay? The rule for c, how to find it once you know the gradient, or if you're given the gradient, is to find c, substitute into equation the coordinates of any point the line passes through. In this case, that's the point 2, 1. All right? So what we do with that is, we know that, remember, 2 is x and 1 represents y. Yeah? Those are the coordinates. So if we substitute into that and say that y equals 1 when 3 times x, which is 2, plus c, right? So that says 6 plus c. Solving that, right? 1 minus 6 equals c, which is minus 5. Okay? Therefore, the final equation of the line is 3x minus 5. All right? Now, do you understand what all that mx+c and all that different bits are, right? And this is the type of question that your teacher's been giving you.
Yeah.
All right? Okay. Have they done anything about gradient between 2 points where you're given two sets of coordinates?
Yeah.
All right, let me do that next, okay? And so, again, if you have any 2 points, so imagine I've got that one there, and that's A, all right? And I've got, oh, I should try and make this a bit more interesting, shouldn't I? Yeah, okay. B, all right? And I want to find the gradient of the line. This bit between A and B is called a line segment. All right, so if you ever hear of something called a line segment, then it just means a line connecting 2 points, like segment A to B, for example. All right, like that. So to find the gradient of that, using only the 2 points, where you don't even have to draw a grid or a line, let's take this one. A, assuming the squares all have values of 1, that's minus 1. This is 1, and that's 3. All right? So A has coordinates minus 2, minus 1. B has coordinates 1, 3. Do you agree? You can see where that came from, yeah? All right. Now, here is the way to do this. You remember we talked about, recapping here, the gradient is the y difference divided by the x difference. All right? We do exactly the same thing, imagining that that's a triangle. Let me show you what I mean by that. So if you imagine that, does that make sense? Yeah? So we are creating a right angle triangle with those 2 points along the diagonal. Yeah? Any questions on that bit? No? All right. So now the x difference is the horizontal bit, how far across we've had to go. So looking at that diagram, how far has it gone? i.e., what's the difference in x between the two?
1 minus 2.
Excellent. All right. So 3. Yeah. And what you've just done is one step ahead of that. So well done. And what about the y difference?
3 minus 1.
Yep. Not minus 4. Minus 1.
Yeah, 4.
Oh, you were giving me the answer there. Okay. So that's 4. All right. So the gradient, doing what we did before, the y difference over the x difference. All right. Now, what you've just told me is the algebraic version of it, and that's what I wanted to show you next. If we let A have coordinates x1, y1, right? And B, if we call its coordinates x2, y2. Right, so any 2 points with different xy coordinates, the formal version of the gradient formula is this. The y difference is y2 minus y1 over x2 minus x1. That's what you've been shown, yeah? All right. And the important thing that you did very well, and it's important to remember, if we apply that to this particular question, or this example if you like, it's watching out for the minuses, all right? So in this case, because we have the point B has y value 3, we want to take away the y value of point A. You've got to remember the second minus.
Yeah.
Right, which you did very well actually. And similarly for the x ones, B has x value 1. You take away from it the x value of A, which is minus 2. And always remembering, as you did, that minus minus is a plus. All right, so 3 plus 1. And underneath it, the x difference is 1 minus minus 2. Okay, same answer. So the point I'm trying to illustrate is that you can do it graphically if they give you a line on a grid and you can read off whether it's squares or units, whatever, and the intercept, and work out your gradient that way and the equation of the line. Or you can use this formula here without having to actually draw a line, and all you have are the actual points, just the 2 coordinates. All right?
Yeah.
Any questions on any of that so far?
No.
No? All right. Does that help a little bit with that piece of work you're doing?
Yeah.
Yeah? All right. Okay. I'll pause that there then.